So this is the photograph of digital type oven, wherein this is the display and these are the controls. Using them we can fix our temperature, and this is the we have opened the door and we have kept wooden pieces in different racks, which are perforated steel racks, and hot air flows through them and keeps on drying them. So this is the oven dry method, the laboratory oven used for oven dry method for determining moisture content. Now this is the table. I will skip, only first column is important for you, that at what moisture content we should season our timber. Final, what is the maximum permissible moisture content in different products. For aircraft we are not using. For handles of agriculture implement, 12% to 6% is okay. For ammunition boxes, 10 to 15% is okay depending on the location, but I recommend 10% moisture content. The wood recommended for ammunition boxes should be seasoned up to 10% moisture content, and moisture content should not be more than 10%. Similarly, boot lasts 10%, and toys, shuttles and bobbin 8%. Any indoor furniture should be seasoned not more than 10% moisture content. So this table shows that if we say that this product is properly seasoned, the wood of this product is properly seasoned, then we should assume that this must be the moisture content of the wood. If moisture content is more than that, the product will misbehave. Okay? Then factors which affect drying rate of timber, there are different factors. As I told, temperature affects drying rate, relative humidity affects drying rate, air circulation affects drying rate. Then species is also responsible for drying rate. Then initial moisture content, the more is the initial moisture content, faster will be the drying rate initially. Later on it decreases below fiber saturation point. Then grain direction is also important, because if capillaries are constricted with tylose formation or gum formation or pit aspiration, then water movement will be very slow. So in that case, permeability will be poor, so drying rate will be poor. So all these factors are very important. So I need not to go in depth because you are not involved in research, but you can always appreciate and discuss with me. Now with all these experiments of permeability and nature of wood and bottommost holding capacities, then we can roughly we segregate wood in three classes: class A, class B, class C, by knowing their reaction towards seasoning. Because challenge is that when we see, as I told, that wood is highly inhomogeneous material, so it is not simple drying, it is seasoning, where we have to keep tab on health of given timber. If we are careless, then it will that drying treatment may damage the health of wood. So challenge is that while doing the kiln seasoning or commercial seasoning, we come across many defects in wood. So we have to either avoid these defects, or we have to keep them at minimum level, acceptable level, so that the quality of the product which we are going to manufacture out of this seasoned wood should not be less. So their class A wood are highly refractory woods, like all species of eucalyptus, then Tuna ciliata. These are slow drying timbers and difficult to season, free from cracking and splitting. Examples are heavy structural timbers such as sal and laurel. Then there are class B moderately refractory woods, that teak and shisham fall in this category. These wood can be seasoned nicely, defect free, but little care has to be taken, and they dry faster than class A wood. And examples are shisham, dalbergia, sisu, and teak. And some are very good wood, class C, which are non-refractory woods. Here we can do drying because their permeability is very, very good. So while removing the water, they do not deform. So they dry within 5 to 7 days inside the kiln without defects. And they are very much appreciated because everybody likes them. They are light wood like Boswellia serrata and this Semal wood bombax species and some conifer species, where permeability is very, very good, means interconnected capillaries are available and the path of capillaries is not constricted. So this is the basic this segregation of different type of woods. Then while storing the wood, we have to keep some take some precautions, because you might have seen if you visit to timber yard, you might have seen that each log has two cross sections, and these cross sections invariably develop cracks. So we lose very costly wood out of the just because of these cracks. Because when you manufacture a house, you will purchase some 4 logs. Your carpenter will say, "Sir, it doesn't matter. I will do." So what he will do, half 6 inch from this direction and 6 inch from another end, he will cut and throw the wood. So in each log, you will lose one running foot of costly material, and in 4 logs, you will lose 4 running feet of costly material. But in timber yard, you imagine there are thousands of logs kept. So we are going to lose thousands of running feet of costly material. So we have to lock carbon, and wood is the best source, as I know, for locking the carbon given by nature. So if wood is not wasted and thrown in the nature without use, then we are going to lock it for carbon locking for very many years, which is required for the good health of our Mother Earth. So what we should do, that when we are involved in storage of logs, so immediately after logging operation in the forest, we should apply bitumen paint, which is black color paint, readily available by Shalimar Paints or Asian Paints, these big companies. We should purchase and apply on to both the cross sections of each log. This will seal the cut ends of both the cross sections, and water will not be allowed to come very fast. So ultimately cracks will not be developed. Another thing is that while storing the wood, we should remove the bark also. Debarking operations should also be done on logs, so that these biodegrading agencies like white ant and other borers which go below the bark and hide there and colonize there will not be able to come further to eat the wood, to sap portion of the wood which contains large amount of starch. Another thing, that for prophylactic treatment, we should do that. We should make 2 to 3% solution of boric acid borax and in water, and spray it frequently, say every 3 months, so that borer attack or fungus attack won't be there. So this is the method of storing. Now, air seasoning. See, earlier we were not having seasoning, commercial seasoning kilns, KILNS, which are big thermally insulated rooms wherein we stack our timber and dry them scientifically. Earlier, these things were not there, so people were dependent on air seasoning. What we do, that we stack our timber after sawing. After sawing only seasoning is done, not in log forms. So suppose you want to construct your house and you have a time, so 6 months ahead you convert your logs into planks and ballis and scantlings and nicely stack them. I will show the photographs how to stack them, and then leave in the nature. And the place should be well protected from sunlight as well as rainwater, so that the only air should touch the stack, and gradually the stack loses moisture molecules, and within 4 to 6 months, depending on the temperature RH of the that geographical region, our wood dries nicely to a very good level. This is the photograph I would like to see. This is cement, say some veranda may be there, cement floor, and these are the scantling, 3 inch by 4 inch scantling on the bottom. Above these scantlings, we have made the layer of timber, just see to be seasoned, and these sticks are known as crossers or spacers, because they create a space of, and their dimension is 1 inch by 1 inch cross section. They create a space between two layers of timber, so that air can flow through this gap and season each plank nicely. So like that, we go on making our this stack, and now this stack is full. After, just see, these spacers should form a vertical line. There should not be more zigzag. Other, if they are placed in different places in different layers, they will create unbalanced forces in planks, and planks will become warped. So once this is complete, then we keep very well distributed weight over them in the form of thick fletchers or iron girders, so that all the planks are nicely under the pressure, so that they will not warp. So like that, air seasoning is done. But kiln seasoning. Then came commercial things. My now real lecture will start from here, which the topic I have been assigned, that is kiln seasoning and seasoning schedule. So what happens that, see, air seasoning takes lot of time. Natural air seasoning takes a lot of time, say sometime 4 months to 8 months or 6 months it will take, and we don't have control over temperature and RH and airflow, because we don't know what will happen, because it is dependent on completely on Mother Nature. But if we are able to create these three conditions of favorable temperature, favorable RH, and favorable airflow in a room, which is known as kiln, these are thermally insulated big room where we can keep large volume of wood at a time, and we can season them scientifically by creating favorable temperature, RH, and airflow. And what we achieve in air seasoning in 6 to 8 months or 4 months, we can achieve here hardly in 20 to 25 days. And the quality of seasoned material will be very uniform inside the kiln as compared to the quality we get in natural air drying. So of late, then some 6 to 8 decades ago, this kiln seasoning started in India also. Initially, very raw type of kilns were there. Then we'll see, and we stack the wood in the same manner which I have shown in the photographs, and then we season the wood by applying seasoning schedules. There are 7 seasoning schedules we will see in next lecture. These are the references, and I will stop here.